Hey guys, so it's been a little while since I've uploaded a video, and this would be the first project where I felt like I might have some advice that I've done in the last year or so. Obviously, as you can see, we're talking about the first kind of DIY electric motorbike I've built, and this is, as it's sitting here, I would say is pretty much the minimum viable prototype to see if it all works, and we'll go through that all in a sec. But just a very quick one, how we got there is really how we got there is my daily commute to work and back is using a motorbike in Auckland in New Zealand where I live. And, you know, seems like it would be nice to be able to do that on an electric motorbike rather than a petrol motorbike, since my background is in electrical engineering. But a little step before that is my post hole borer died not so long ago, and the logical conclusion was to pull the old crappy petrol engine from the top, find a nice chunky 24 volt DC motor in this case, connect it to the shaft using a shaft adapter and a couple of plastic machine spacers. Voila, I've got a great working post hole borer, works fantastic, and it's never going to stop working again. And one step before the electric post hole borer, this is maybe going back a few years now, it's probably 4, maybe 5 years or so, is I wanted to, wanted to experiment with the kind of power wall side of things. So I designed the circuit boards that the batteries go in. Basic solar charger, got a couple of solar panels on the roof that goes through an inverter and just runs one of the Bitcoin miners up there. So that was kind of interesting, gave me a little bit of a background of working and with lithium batteries and kind of keeping them as safe as can be. And let's go and, so that's kind of the battery background. Let's go and have a look at the actual bike and I'll talk you through that. Okay. So normally my videos are relatively unscripted. For this one I have made a couple of notes down there just so I can kind of keep on track and kind of cover some of the things that I thought might be worth knowing if you're looking into doing this kind of thing for yourself. So the first thing is the choice of motorbike, and I think there's quite a few videos that deal with this relatively well, so I'll just go over this relatively quickly. This particular one is a Hyosung GT250R. You can see the tank over there. It's chosen for a number of what I feel are pretty good reasons. So firstly, it's a 250cc motorbike, so the whole thing is comparatively light because it's designed to work with a relatively low power engine. But the nice thing about this specific 250cc is that it's quite large. It's kind of full size. I'm 6'5" and probably about 80 kilos, so that's close to 200 pounds. And a bike like this is kind of comfortable for me to ride. My daily rider is a Honda CBR 650, so by comparison, this is still a reasonable size. The other reasons why this was a very good bike to choose is there are some intentions of making it road legal, and from that point of view it's got no ABS on the front or back. That's not great for safety, but it is pretty great for kind of getting it approved. If you're going through the New Zealand system of getting something street legal, you can't, for instance, take a bike that came out of the factory with ABS and remove the ABS. If it came out, they would want, even if you change the power source, they would want to see it with the ABS still. So that would just be something that would be kind of hard. I'm not sure how the ABS pump works on most motorbikes and whether it's integrated into the engine. So no ABS, but on the flip side, it does have 2 big discs in the front, as you can see there. So nice, good stopping power. So, it's going to end up being as heavy as the original probably, and that's going to work really well with, so it's got nice brakes. And the second to last reason is that it's got this like not so many bikes nowadays, it's actually got 2 bits of frame underneath which actually support the engine. Most motorbikes now, most modern bikes have supports on the back and supports up here, but the engine itself is structural. So this makes it very nice and easy. One of the things, again, with getting it road legal is you can't do very many modifications, or you don't really want to do any modifications to the actual frame of the bike. And really the last reason why I went for this particular model is they're just cheap. So this was $1,000 motorbike. It's currently unregistered, but that's not a big deal anyway, since it's going to have to go through the whole compliance process anyway. So for $1,000, you got an okay condition bike. It did come with all of the rear fairings and stuff. I've just pulled them off while I worked on it. Tanks in okay condition. Forks need new seals, but they're not too bad. You know, the whole thing is relatively straight. So that's kind of how I ended up with this particular bike. Those are the things that mattered to me. So without wasting too much time, let's look at what went into this conversion, and then after that I'll take it for a quick spin up and down the drive, and you can get kind of sense for yourself what you can expect out of a bike like this. So for the motor, I can't see very much of it there, but that's a 3-phase brushless DC 5 kilowatt continuous motor. It's a Goldenmotor HPM something 5 HPM 05 kilowatt. It's an 8-pole brushless DC motor, pretty standard. The engine that came out of this motorbike weighed 51 kilograms, and I think that motor is about 12. So you can work that out in pounds, but the ratio is pretty good. It leaves quite a lot of excess weight for batteries, which are quite good. So standard motor off the shelf, has about a 7/8 of an inch shaft. I think it's a 22 millimeter shaft or so. I had to design and machine the aluminium motor holder plate. That's 10 millimeter thick aluminium. It's a little bit under half an inch. Fairly easy to design that up. I looked relative to the mounting bolts at the back on the frame. I looked at where the old sprocket was on the engine and tried to position the motor to put the front sprocket in the same place. Then I got a bit of wood and I marked out where all the holes and things are and where the sprocket was. And then from there on, I was able to just kind of superimpose in CAD the actual brushless DC motor, work out the plate, and then I have a nice CNC machine at home and a CNC router, so I was able to just CNC that out of a bit of 10mm aluminium plate, and as you can see, everything worked really well. Top tip there about CNCing into anything like this, and you'll see the same thing when I talk about the sprocket later, is cut it out of some cheap MDF or some cheap scrap plastic first, and just fit everything in. I did that first in some scrap MDF, and actually noticed that I'd messed up the whole pattern for the motor. So if I'd done that in the aluminium, it would have been much more painful than just fixing it in CAD. The sprocket, I started with a standard steel 12-tooth sprocket. I found one that had a center hole that was pretty close to the shaft, and then I machined a keyway into the sprocket, and then I just put a couple of welds to hold the sprocket to this shaft, the locking collar. And you can see the shaft is not coming all the way out of the collar. If I were doing this again, or let's say the next time I do this, what I'll do is I'll actually space out the where the motor mounts to the frame, bring the whole thing this way so that so it's a little bit better fit. Obviously also currently no protection over there or on the back for that matter, but that's not really necessary for the minimum viable prototype. The motor, we'll talk about the first bits first. So the motor connects then using the standard 520 chain that this bike uses to the rear. Obviously, you can see that the rear sprocket has gone up quite a lot in size. I've got let's look at my pile of goodies here. So I've got the original sprocket here with a 46 tooth, and that's just a sprocket I cut out of some scrap plastic to make sure the teeth fit properly in the chain, basically. One of the problems here was you have to design the sprocket yourself. You can't really, or it's not easy in New Zealand anyway, to buy a 60 tooth 520 chain sprocket, and definitely not with the mounting pattern for this particular bike. So luckily there are some good online resources that show you exactly how to design a sprocket. And yeah, so it's pretty much designed it, once again CNC'd it on my big CNC machine, and yeah, it came out great. It's only like 5083 aluminium, so it's not particularly hard aluminium or anything like that, but so far it seems to hold up just fine. I think the front sprocket is a 12 tooth. It's the smallest I could get for this chain, and the rear sprocket at the moment is a 60 tooth, and with a theoretical speed of the motor of about 4,000 RPM, which is very reasonable. In theory, this ratio, given the size of the rear tire, would give me a top speed of about 100 kilometers per hour or 60 miles per hour, although I've only done about 70, 75 or something at the moment. Yeah, so that's pretty much it. Made the sprocket myself. The standard chain obviously was too short, so actually at the moment for this prototype, I've actually taken bits of 2 chains, and I've got 2 master links, and I've spliced them together to get a chain that's long enough. That's obviously something you'd also kind of have to deal with as you go. Okay, so the motor obviously has to be controlled somehow, so let's talk about that first. That's a very easy thing to talk about. So for the motor, let's just get rid of the seat there, we don't need it for now. For the motor controller, we have a Kelly, see on the back if you can read that. That's a Kelly KEB48601, which means it's a 48 volt motor. It's 6 kilowatt continuous, and the 1 at the end means it does regenerative braking. This I bought straight from Kelly controllers, I think just basically shipped out of China, and it has been brilliant. It has, you can't really see it down there, but it's got a standard DB9 RS232 serial connection, so it can be programmed just straight from your laptop. That was really nice because they always require some programming. And got your main feed in from the batteries. We'll call them the high voltage batteries here. Goes through your contactor, goes to the battery plus. Same thing for the battery negative, just goes straight in. Got your 3 phases out to your motor, and then you've got all the control lines and things go through there. This does, as I said, does regenerative braking. Yeah, works really well. I've got nothing but good things to say about the Kelly controller. It was very straightforward once I got it all set up correctly. The whole thing just works just fine. Yeah, is there anything else here that really matters? I've got it. There is it's actually, it's sitting on this plate, but it's actually got a cutout in the plate. You can see the hole, and this is actually sitting on its own big heatsink. Although I've never had this even get hot to the touch, so it seems to be just fine for what I'm doing with it. It is 6 kilowatts continuous. It's a bit interesting how brushless DC controllers work. They're basically a buck converter, and because the motor has quite a low coil resistance, it means that even when you put, so if you put 100 amps into the converter from the battery, you could very easily get 400 amps out here because it's at a much lower voltage out to the motor. So that's something you have to program in, and you have to watch. I had this thing set to 100%, and I could get these wires very hot very easily if you don't limit it all correctly. So that is basically the contactor side. Now the way that I've got this currently set up, it was kind of used most of the systems that were already part of the bike to get the safety side of it done. So currently I can turn the ignition on, and you'll see the display turns on, got some lights and stuff like that. All the regular things work, but this is all just running from the 12 volt battery at this point. You'll see that's not powered up. That's the amp meter, or the amp hour meter for the main battery, and also this is not powered up because it also goes through. You have to have the engine run switch to on, and also this is going to be a little bit harder to demonstrate, but the side stand is up. So when I flick up the side stand, you can see the light turns on there, and you've got the amp meter on there. So if I turn off the run stop, it's all dead again. So there's basically 3 things that you have to go through before the motor controller will be powered up. So you can't ride away with the stand up, you can't ride away if the run stop switch is not on, that kind of stuff. So that was all fairly straightforward to trace out where those wires go, how they're all wired. And what happens is when all 3 of those basically have power going through them, That power I've got going into a little solid state relay there, and the solid state relay turns on the contactor. The reason I use the solid state relay is because you can use a 12 volt input signal to control a 48 volt output signal. That's pretty uncommon when you're buying standard relays. Usually they're 48 volt to control them, and they want to switch 48 volt like the contactor. So yeah, little just a board that I'd made myself. You can see I've got in and out there, filled it up with some hot glue and heat shrinked over it, so that'll be good. That seems to work really well. For the most part, I've got most things just wired into the bike. You will see everywhere that I've unplugged something from the original bike, I've labeled what it is. In terms of things that I took out, there was the high energy ignition system, there was the battery rectifier charger thing, obviously all of the petrol stuff, exhaust, that kind of thing wasn't necessary. Now, one of the nice things about this bike, just while we're talking about this area, is if you actually look how I've got this mounted, this plate on top of this frame using some existing mounting holes, it kind of seems like that is all very much in your face. But actually the way that this tank works is it's got a huge amount of room underneath where the airbox was sitting. So actually that tank, I've basically got everything pulled out of that tank. But that tank will still sit 100% over the top of this and actually hide all of this. So most of this stuff is going to be reasonably water protected. The motor controller is actually waterproof, but the contactor is not. So actually I probably still want to do something better with the contactor if I'm going to be riding this in the rain in New Zealand. I've used Deutsch connectors, so they're all waterproof connectors everywhere, but that should be fine. Okay, the next step is brakes and accelerator, that kind of stuff. So I'm just using a kind of a cheap 1 to 4 volt or something like that, quarter turn throttle. I just basically measured what its output voltage was at rest, at full, and then just programmed the appropriate voltages into the motor controller. And so that works really well. Brakes completely unmodified, with the exception that the front and rear brake, when they turn on and they essentially send 12 volt to the brake light, I've intercepted that signal and put that 12 volt into a relay, and the relay shorts the regenerative braking input on the motor controller, which means that when I pull the brake or step on the rear brake, you've got the motor controller doing regenerative braking. So it's just a signal for that. So it's got two types of regen actually. If you just close the throttle, it'll start, I think, up to 20% regen, and then when you pull the brakes, it'll do up to 100% regen. And you'll see later on when I do a little video, if you keep an eye on the ammeter, you can clearly see when it's regenerating. The arrow kind of shows up, and it can get some decent current and some decent slow down out of it at that. Okay, so that covers motor controller. I'm using kind of like orange 4-gauge cable. You don't really need to go quite that far, but 8-gauge probably would have been fine for this. It's only doing 130 amps or so max. Okay, so the next thing to be aware of is you still have a 12 volt battery, because when you want to register, or when you put these bikes through compliance, if something fails in the high voltage system, they still basically want your hazard lights and things like that to work, at least for some time. So you've got the 12 volt battery, and then underneath here, see if I can show you the right place, in there is a 48 volt, that thing is a 48 volt to 13.8 volt DC-DC converter. And it wasn't quite as simple as just connecting it up. So I've obviously got it connected up to the switched side here of the positive of the 48 volts. But I found with the DC-DC converter, it would fail to start properly if you actually just had it directly connected to the battery. It didn't like having a voltage on the output before it starts up. So luckily I had some of these lying around. This is it's kind of potted in some hot glue for the time being, but this is a what's called an ideal diode board. So it'll conduct current only in that direction without any voltage drop across it. And so this works fine. So basically it means the battery can't backfeed the DC-DC converter. This could probably have been avoided if I'd bought a better DC-DC converter, but this is a fairly cheap AliExpress one, and it's fine. It just means that I've had to use this this little ideal diode board in the line, so that works fine. Now that's why you'll see if you look at the ammeter up there, if I turn the lights on, it draws more current from the main battery pack. Okay, so I think that pretty much gets us now to the main battery pack. So batteries are really one of your biggest problems, or one of your biggest pains. It's hard to find good cheap ones. I don't think there's any such thing as good cheap lithium batteries. So what's in here at the moment is 3.7 volt cells. There are 6 cells in every group, and there are 13 groups of series to give you a 54 volt or so pack. I'll show you more what's inside here at the moment. This was all tested and made by myself. And then I've got a 60 amp daily BMS, also AliExpress special, on the side, which is basically just to do a bit of balancing when I'm charging. It is also meant to be a 60 amp max discharge current, and you would expect it to cut out, but I have drawn 120 amps for quite a long time and never had that cut out, so I'm dubious, even though I've seen some videos online of that actually working and cutting out. I am a little bit dubious as to whether that actually works. I'm using a 50 amp Anderson connector here as the main connection for now. That is obviously also not really suitable for long-term 130 amp kind of drawing like what I'm doing, but it works fine. So in terms of what's inside there, so this is all, I started with, I've got a friend luckily who repairs Dyson vacuum cleaners, and so what I've got inside there are these cells. So they are INR 2700, so they're a bit bigger than your standard 18650. And then as you can see, what I've done is I've tested all of the cells that are in the bike. I've actually tested at a 3 amp discharge. So this is something that a lot of people don't actually do. They'll capacity test individual cells, but they'll do them at quite a low current. So I've tested each cell at 3 amp multiple times, kind of see what its capacity is. And I've obviously picked the best bunch, the best 13 multiplied by 6 cells for what's in the battery pack. And the Dyson ones come in these cool little plastic holders. So you just pop the top off, you can pull the individual cells out, and they basically sit in there. And then what I've done in my pack there is there's some bus bars running on each. So there's 13 of these, and the bus bars to connect everything together. And I've got little fusible links on each cell so that if a cell short circuits, at least the whole thing, doesn't end in disaster. So yeah, thank you very much for basically donating that, Keith. Much appreciated. Yeah, so that's pretty much it for the battery pack. 50 something volts. It ends up being what is it, about the average? So its average is about 2 amp hour per cell for the cells that made it to the pack. So it's about a 12 amp hour pack if you're drawing 18 amps out of it. Now, since I'm mostly drawing over 100 amps out of it, it's going to be less than a 12 amp hour pack. But those cells should be good for 35 amps continuous each. So I'm definitely not harming the pack. You can see it's got kind of currently held in by some bungee cords. This is not the final pack. This was once again just a minimum viable prototype. So that gets me a few minutes of riding up and down the road at full power, which is fine. Okay, now in terms of figuring out what's happening with the battery pack, one of the things I found really invaluable was basically current and voltage measurement, and that's kind of hard to do while you're riding if you're just using a clamp meter or something. So let's see if I can look down there. I'll show you that there is the shunt. So that's a 350 amp shunt, and the shunt feeds into one of these little, once again, AliExpress specials. I'll see if I get it all powered up if I get the side stand up. So it looks like that. And so you can see the voltage of the battery pack there. And if I click that button once, I can see how many amps it's currently drawing. So it's 0.8, and that's charging, that's mainly charging the 12-volt battery. So if I turn the lights on, you'll see that that'll jump up to like 2 amps out of the 48-volt pack. And you can also set it up so that it knows the capacity of the battery. And in this case, you'll see I've got 35.4% left. So once again, that's money very well spent. That thing has worked really well, that little amp hour meter. It means I can keep an eye on what's happening with the battery as I'm testing it, just to see. So I think that is pretty much all we'll do before we take this thing for a quick drive. So results, as you'll see on the video of me testing it, because I've obviously tested it a few times now as I've gone through the iterations. 5 kilowatts for a guy like me, 200 pounds, 80 kilos, doing what I want to do with it, which is commuting 30 kilometers to work and back in the afternoon. The 5 kilowatt motor is not going to do the business. 5 kilowatts is just not enough. I can get a decent high speed on the flat or with a slight downhill. You'll see it accelerates pretty quickly and it's pretty happy, but it just does not actually have the torque with my weight and the weight of this bike to maintain that speed going up hills. And you don't have gears and you don't have a decent flywheel to save energy, to conserve energy or anything like that. So where I'm probably going with this next is I'm probably actually going to pull out the motor and the controller and all the bits that is kind of making up this prototype, sell them off and look at getting something about twice the size. So I'll be looking at getting something that's 10 kilowatt continuous and 20 kilowatts for 30 seconds or a minute or something like that. I think that's going to be more appropriate, so I'm happy to do some more videos when that comes together. I have already ordered some more batteries, so obviously that's only a test pack. It's only 48 volts, so I will be potentially just expanding that a little bit to get to 72 volts. The 10 kilowatt motor is likely to be a 72 volt motor. So I might expand that just as a test pack. I might sell that with the motor and the controller and stuff as a kit, because someone might still want to turn it into a go-kart or something. It's still a very reasonable motor. You could probably make a very decent moped with it. It's a much lighter kind of thing. That's only the rules around mopeds a bit different. It can do a maximum speed of 50 kilometers per hour, so this would be perfect for a moped. It would have no trouble at all being a very nice moped. So yeah, as I said, I have ordered quite a lot of cells once again from my old friend AliExpress. So I'm getting, I think, close to 100 of the 32700 6 amp hour 3.2 volt lithium iron phosphate cells. So when those come in, it's going to be same kind of thing. Build a big battery, put a 200 amp BMS on it, and yeah, that is pretty much it. So let's have a quick look at my paper and see, before we jump to the actual test ride, let's see a couple of lessons learned that might save you a little bit of time, money, effort, hassle. So one of the lessons I learned was you end up buying not always the exact right thing the first time. So when I bought the motor, which was actually the very first thing I got for this project, it's what kicked the whole thing off, it came with that controller you can see on the ground there. That's a Goldenmotor 500 amp controller or something along those lines, which is supposed to work with this motor perfectly. The problem was that uses a special programmer, which is hard to get. Goldenmotor doesn't answer your emails. It basically became too hard, and it was easier just to buy a whole new Kelly controller that's easy to deal with, and I could just send them an email, pay the money, and they ship it. So yeah, think about what you're buying. You will make some mistakes. I've made a bunch of mistakes in this already, but that's all part of living, part of learning. Okay, not everything works as expected. Lesson number 2. So this is referring to things like the DC-DC converter that I put in. I've got an electrical engineering background, so it was relatively easy for me to figure out that every time I tried to start it while it was connected to the battery on the output, it wasn't working. And immediately I was thinking about using a time delay relay to connect it to the battery once the converter was already working, that kind of thing. And then it dawned on me that the problem might be the back feed. So I actually put the diode in, the lossless diode. I can't remember the name now. I put the lossless diode in. But yeah, that's not everything works as you expect, and it's good if you're not particularly, if electronics is not your thing. It's good to have some friends where it is their thing, and they might be able to help with stuff like that. Lesson number 3: making batteries is hard. That each cell had to be individually tested. Then I had to machine those little holder things to put the bus bars in. Then I had to do a ton of soldering. Yeah, quite a pain. If you're able to do something where you can just purchase batteries or use bigger cells, or yes, they cost more, but I've learned with batteries you just have to spend the money. Batteries are expensive. It's just how things work at the moment. And then the last 2 basic lessons, which I think everyone probably already guessed, is things take time and things take money. So this as it is here has occupied quite a lot of my free time for the last couple of months, much more than you would think. Every single bit, and then you make mistakes and you have to do things again, and it just it does take heaps of time, especially the first time round. And probably, I wouldn't say it hasn't cost me a fortune so far, but I can see that it is turning into a bit of a money pit, because now immediately I'm talking about a much more expensive motor, much more expensive motor controller, already spent a ton of money on bigger batteries. It does go up a little bit, and at the end of the day, I'm not sure it's going to be much cheaper than actually just buying an electric motorbike, even though I don't think there's that much choice available. But it's a project, and I'm learning and I'm enjoying it. So yeah, those are my my little nuggets of advice. Probably worth about what you paid for them. So yeah, let's take this thing. Okay, so going to be taking the bike down to the end of the drive and back up. I've got as you can see here, I've got the camera kind of shoddily mounted to the frame with some clamps, but you should be able to see out the front, plus the speedo, plus the amount of amps that the motor controller is drawing. And this will give you some idea of what you can expect with the 5 kilowatt brushless DC motor and the setup that you saw before. So I'll just get the camera set up here. You basically turn this on, see everything there, and see some current draw, basically just charging the 12 volt battery. If I turn the light on, that goes up. Makes sense. Okay, let's get this all set up for you. So as you hopefully were able to see on that camera, the current kind of stays around the 100 amps or so mark, probably shoots up to 130 or so. Definitely still struggles on the uphill bits. We just don't quite have the power that we need. Talking about the motor controllers and things, just keep the brake on. Everything is super cold, as you would expect. There's not really, nothing has worked particularly hard so far. But yeah, that's kind of gives you an idea of what you can expect when you've got a 5 kilowatt motor continuous in a setup like this.